All right, number 15, we want to simplify the expression. So we are doing the derivative of the integral. So we have a d dx out front, which means we're doing the derivative. And then we have integral from x to 5. Now, when we do the derivative of the integral, we are basically just going backwards to what we started with. So we've seen this property. So there's a couple things I'm going to do. Normally we have the variable as the upper limit of integration. So I'm going to rewrite that, and I'm just going to use this as a symbolic letter. So I'm going to use little f of t dt just to kind of go through the property. So first I'm going to rewrite this. So we're going to have d dx. I'm going to flip the limits, which is going to add a negative out front. So it's going to be integral from 5 to x of f of t dt. When we integrate f of t, so this is a negative, we're going to have our derivative d dx of big F of t. And the big F of t is going to be evaluated from, and there should be a negative out here. Don't lose that negative sign. From 5 to x. All right, continuing, we would get derivative. I'll just plug a negative out front. Of big F of x, upper limit first, minus big F of 5. And then when we do the derivative of big F of x will give me little f of x. Derivative of, this will be a constant. When we plug in 5, it'll give us a number. Derivative of a constant is 0 or minus 0. And then we still had our negative out front. So this will just give us a negative f of x. So we started with f of t, and now we're ending with a negative f of x. So if this is f of t, I'm just going to replace that with x cubed plus 1, and it'll be a negative out front. Negative square root of x cubed plus 1.